Okay, here we are, page 12. Almost done with this crazy packet. We have finding the inverse of functions. Well, the number one thing we want you to get out of finding inverse of functions, the first most primary thing, is understanding that when you find the inverse of any relation or function, you're switching x and y pairs. The idea for an inverse is you're trying to construct something that undoes a function or undoes a relationship. In order to find an inverse function, the function you're working with has got to be 1 to 1. And that basically means that for it to be 1 to 1, the function must pass the horizontal line test. And we'll talk about this in class when we get into our unit lessons. You should have already seen this in pre-calculus, but we will be going over it in brief as we work through our first chapter. So when we write up this function, we change f of x to y. And then we do, algebraically, the most important thing, we switch x with y. And then we just solve for y. So I'm going to have to solve for y. So I have x minus 3 equals 2y, and y equals x minus 3 over 2. This gives me the inverse function of what I started with. Now, I don't have time right here in the solutions to demonstrate or check this property, but I want you to realize that when you have the function and you plug in the inverse function, you should get back to what you started with. We started with x as the input. We put it into the inverse function. Then that value got put into the function, and we end up getting back the value x that we started with. It's like we're undoing what we did, so we should always end up with what we started with. And the same property applies when you use the inverse function on the function. So both of these properties are checked, basically make sure we found the inverse. So with that being said, we're going to work with this next function, but I'm going to use another sheet of paper for that because it's going to be a little bit more lengthy. And on this one, we're going to just rewrite this as y equals x plus 2 over 5x minus 1. And we're going to do our most basic thing. We've got to switch x with y. And then we've got to now try to solve for y. So this is where it gets a little crazy. We've got to cross multiply. We've got to distribute. We want to move all terms with y to one side. So I'm going to keep the 5yx on the left, and I'll subtract the y over, but that means I'm going to bring the x over to that side. And then I want to solve for y, so I'm just going to factor that out. And then I'm going to solve for y. And if you notice, my inverse for this rational function is the same as what my function was. And that is one of the crazy properties of these inverse, or these rational functions that are of degree 0. And we'll talk about that in class, but if you notice, my inverse function is the same as my original function. So it's definitely something that we want to talk about, but not for the homework. So anyway, if you try plugging in the function into the inverse, you should see that you end up just getting x. Or if you do the opposite, plugging the function into its inverse, we should end up getting x as well. Back to the summer homework. Let me just zoom in. And now we have, we want to express x in terms of the other variables. So here we have similar geometry. So hopefully you notice this is using ratios. So x is, if we look at the similar geometry, we have a small triangle and we have a larger triangle. So we're going to construct ratios based on that. So then we could express x in terms of the other variables once we set this up. So we have x plus t over r is going to equal t over h, and we cross multiply. And we would distribute. And we would subtract. And we would divide. And our end result would be RT minus TH all over H. That's what our x value should be. On the next one, in this diagram, we have, that looks like an R, so I'm going to call that an R. That's x. So we have, I'm looking for geometry that is similar, and I see that I have the big triangle. I have T. Let me change the ink color so we don't confuse the two problems. So I have the big triangle has T and has X, and on the little triangle I have R and I have H. Well, I don't have the same sides, but I could find this third side here. That's just going to be r squared minus h squared square root using Pythagorean theorem, because they are right triangles. And now I can set up my ratio and solve for x. I have x over t is equal to r over square root of r squared minus h squared. So now x is just going to be rt over the square root of r squared minus h squared, and that would be the answer for that one. So that concludes page 12, I believe. So I'm going to get to work on, I think it's the last page, but I'm hoping it's the last page, and hopefully this is of help to you.